So this is probably going to be a fairly brief meeting. I tried to get a hold of Dan Lane. Since it's supposed to be a science meeting, I was going to present or have Dan talk a little bit about the scintillation experiment. Bill, how much can you talk to that? Do you anything besides the
Oh,
general stuff which I know?
no, you probably know more about it than I do because you relocated the thing. I
Oh,
know nothing about it.
okay. So I was just going to cover that, and I was going to cover an experiment we have waiting in the wings, which is the geomagnetic monitor. And so if this thing lasts a half an hour, I will be surprised. But I do want to thank everyone for coming. We try to make this a standing meeting, so I wanted to get some science in here. And so let me first talk about the scintillation experiment, and let's see if I can share. And we'll tell me if you can see.
Yeah, that looks good.
Whoops, I don't know why it's advancing. I've got, okay. I think I just turned recording on. So we'll see your screen sharing, stop share. Okay. It's hard to tell. It looks like it's a bright red button versus a darker red button if it's not recording. So something that a number of folks may not be aware of is that Dan Lane has been running a scintillation experiment where this is kind of to get to locate, give you an idea of where this is located. The picture that's showing right now is the doghouse, which is at the far western edge of our bunker. So if anyone's been in the bunker and seen the spiral staircase that goes up, this is our emergency exit out of the bunker. And Bill, maybe you can tell me if we ever have to use it, is it a matter of climbing up in there and pushing the building over? Because I don't think there's a door, is there, up
Yeah, you
there?
wouldn't. So far, there's not a door. We need to get a door. So if anybody has a 32-inch open to the outside, what would it be? It'd be a
External door?
right hand or external right hand door, like a metal door with a frame. We'll take that and put it in there. But right now, if you go up the spiral staircase and have to exit for a fire or something, you're going to have to kick the wall down.
It makes it a true emergency exit.
Yes.
You get through the
Yeah.
spiders and snakes.
Yeah. Well, yes. You have to fight the spiders and snakes to get there. But if
It
you're on fire, you'll probably do that.
Yeah,
yes.
definitely.
Your flaming clothes will scare them away.
Yes.
Um, so at the if you look at on this doghouse picture here, now you got kind of located at the very top. There's a GPS antenna, and this was recently moved over to the doghouse from well above the trailer. It used to be mounted quite high above the trailer, and it's interesting the lower position here, as Rick educated me on. If you take a GPS antenna and you mount it high in the air, you get lots of reflections off the ground, which actually confuses the signal. And I think you told me, Rick, that the Green Bank GPS, I guess the major GPS antenna is actually ground mounted. It's sitting
Uh,
on the ground.
I was referring to the GGAO antenna, reference antenna, which is part of the IBS system, and that is mounted about 6 inches off the ground at Goddard Space Flight Center.
Oh, okay.
And that is not unusual. Quite a few of the reference stations are on concrete pillars, 10 feet sunk in the ground that stick up only a few inches, just enough to keep them above the snow.
Okay, so this might be something that we would consider in the future for this because um, the University of Texas, I believe, is running this experiment. So this experiment runs and ships its data off nightly to University of Texas, and they noticed a huge improvement in our horizon coverage from the GPS antenna when we moved it from being approximately 30 feet in the air to being about 8 to 10 feet in the air, which is where it's located now. And so, yes, in the future, we may consider mounting it much closer to the ground, even to get a better reception. But what this experiment does, and Rick, feel free to jump in here if I misspeak on something, is that it's looking at the GPS signals, which of course are quite well disciplined signals, as well as us kind of a priori knowing time data, etc. And the signals are received by this GPS antenna, and as the ionosphere changes, the and its refractive index changes a little bit, and you get a scintillation is a fancy word for twinkling of the GPS signals. Perhaps not losing them, but shifting. The signal shifts somewhat, so they're able to actually extrapolate from that data about what is going on in the planet's ionosphere from looking at the signals from the GPS satellites as they penetrate the ionosphere and our antenna receives it. Does that sound reasonable,
That,
Rick?
that's half of the story.
Okay.
Uh, you cannot do this experiment at home because that antenna is dual frequency and the receiver is a U-Blox F10, I believe. It's either an F9 or an F10, but it's a dual frequency receiver. So it's 1200 megahertz and 1500 megahertz at the same time. And the ionospheric, uh, uh, the deviations that occur in the ionosphere are different at the two frequencies, and it measures those differences to characterize the ionosphere. So you have to have an expensive dual frequency system in order to do this experiment properly.
Okay. And this experiment actually I think was going when I first joined DSES. So it must be like 4 or 5 years now. Bill, do you have a idea of when this started?
Yeah, I think that's about right.
Yeah,
4 or 5.
that is. That's right.
Okay. Um,
And
and
the equipment was given to us free by the U Texas.
mhm. And this is an example of some of the experiments that we can run that are very low maintenance, but are gathering good data for various research studies that are going on. So as you're down there and working at the site, this thing is just silently sitting off on top of the doghouse and collecting data, which which kind of will segue into my next. Let's see. Let's stop sharing here. My next topic, which is well, actually, are there any questions about this that I might be able to answer? Or someone else here might be able to answer. Okay, so we'll go on, and I'm going to show you a very exciting box. Not really. So kind of sitting in my shack here for quite some time. Let's see if we can. There we go. We have a geomagnetic monitor that is awaiting installation at the site, which kind of falls into the same category as the as this scintillation experiment, in that it monitors the X, Y, and Z axes of the Earth's magnetic field and ships that data off to a central location to be processed. Now, this requires to be buried, so I don't see anything happening with this until we actually start working on the 30-foot dish foundation, and then hopefully we can hijack the backhoe or something as they're digging the foundation to actually dig a hole deep enough for this monitor. But in the meantime, what I'll do, and I'll also send out an email about this, is that I'm I'm off busy doing some dish stuff and all that. And even though there's nothing that needs to happen with this monitor quite yet, I'm just wondering if anyone wants to get a little bit more involved in DSES and the experiments that are going on there. I would be more than willing to pass this geomagnetic monitoring equipment off to you. And I've have an idea of basically how to build the PVC tree that the three axes will sit in, and I'd be more than willing to help you with that. But if anyone wants to really kind of jump in, you're more than welcome or feel free to get a hold of me, and I'll pass the equipment and all the documentation I have off to whoever is interested.
Can you
So
can you elaborate a little bit on what is required here? How deep does it have to be buried? What's the cabling and what is this PVC tree?
Oh, okay. So, and again, I didn't have a chance to really pull anything together here for this. Um, the PVC, the deeper the better is what it boils down to, and it should be away from anything that's metallic, um, which might be a little bit of a challenge on our property, given how many buried metal things there are. But the if you go back in our science presentations, do you remember the name of the guy that's I think he's up in Alaska and he gave like three presentations?
Reeve,
What was that?
Wit.
Wit. Yeah. So there's actually a couple videos where he talks about installing this equipment, and by a PVC tree, I mean there's you build a PVC pipe structure that will hold like I can show you the sensors here, which are just kind of alone. The sensors look like big capacitors. And one of them goes vertically. One of them, goes horizontally in one axis, and the other one goes horizontally in the other axis to give you X, Y, and Z axes. So let's see. This thing's not going to let me really show you. So, and I understand these are no longer available. So we have to be kind of careful with them. But so what will happen is one's mounted like this in in a PVC pipe to protect it, one horizontally and one horizontally exactly 90 degrees to the other one. And it sounds to me like if we can get these about 6 feet deep or so, and the trick is they have to be thermally insulated as well because temperature fluctuations can affect them and confuse the results. So, if we can dig a fairly deep hole while the 30-foot dish is being installed, and the way I kind of envision it is, we have like 1.5 inch PVC pipe that these will sit inside. And I actually have a 3D printed design that'll hold these centered and allow some airflow around them. But and if we could get like a 10-inch PVC pipe, cap it, and bury that, and then just lower the 1-inch pipe that contains these structures in it, that would give us a nice watertight container to hold all the equipment in, and then we can and it has to be kind of sealed in order to be thermally isolated from surface temperature fluctuations. But then we can get that experiment up and running. We've actually had this in our possession for probably about 3 years or so. Mm-hmm. And kind of the thing that's holding us back is how deep it has to be buried. I didn't feel like going out there with a shovel. So the theme of this meeting was pretty much ongoing science at DSES. Is there any other Bill and Myron, any other ongoing experiments? I'm not really aware of any right now, or do we have any experiments waiting in the wings that people have asked us to do?
Uh, yeah, we do. Let me ask a question about that one while I'm thinking about the others. Does the electronics circuits for this thing need to be buried with it, or are they on the surface, or how does that work?
There are a couple options, and I would have to go back and look at the documentation. It's been a while. I did study that. I think that some of the circuitry has to be relatively close to the sensors themselves, and then you can have some long wires that then run the gathered information into a small computer that pulls it all together and then reports back. Phones home.
I
Okay.
believe the wires for that have already been run from the building to the tower on the north side of the building. With Ray ran that along with the Almar 600. So the control wires for that, from what I've been told, and I want to remember, was already placed in that conduit. So you would have to connect that up at the where that tower 20 short tower is on the north side of the building with that long periodic antenna on it.
Oh, where the E Callisto is,
Yeah,
and actually, that's another experiment that's ongoing.
yeah,
That's the one I was trying to think of. Is we've also
yeah.
got that one going, or
And
trying to get it going.
trying to get it going.
Yeah,
Um,
one of the members who was going to install that relocated from Colorado Springs to Cripple Creek, so he's no longer available. Took on a new job, and the soil conditions out there when we dug. Steve and I dug a hole, about a 4 foot deep hole for a Roan 25 tower years ago. The soil conditions were pretty easy to dig down that far, just a shovel, hand shovel. So we went down big enough for some concrete in a Roan 25, and it didn't take very long to get down to 4 feet. So going down even further, you just need a post hole digger and some extra effort to get that another 2 or 3 feet down
oh,
to the ground.
okay. And I've been kind of keeping an eye on the the big PVC pipes that show up occasionally at Habitat for Humanity. Because I figured if I can get a big PVC pipe that we can sink in that, I'll buy a cap for it and we'll glue it on for the bottom of the device.
Yeah, it'd be nice if it was down in there where we can pull it out and service it if it fails or anything happens to it.
Yeah, that's why I don't want to bury the tree. I mean, if you bury the tree, it's there forever because you've got these pieces that are sticking out at 90 degrees.
Yeah.
But if we the
If you have,
downside of that is if we have an airspace around there, it'll be a lot easier to thermally affect the device
if you had
from
an
the surface.
8 inch conduit pipe down and then a 6 inch or 4 inch whatever to hold the experiment inside that, so you'd have a something you could just lift it out of the larger pipe.
Yeah. Well, I'm thinking that the tree, if you just suspend the tree in it, you
Yeah.
could just you don't need really anything about it. You just center the tree and have it in the center so it can be pulled out. Yes, and thank you for jogging my memory about E Callisto when we have to get that one going because I think the antenna's there, but I don't think the computer is running to gather the information. So the E Callisto experiment um, gathers sun noise and reports that back to. Do you know who's collecting that data? Anyone? The E
Yeah,
Callisto?
it's the Swiss. There's a Swiss repository with one of the Swiss labs and universities that it sends its data back to, and we contribute on a worldwide basis to the sun noise data from the Callisto.
Yeah, but not yet. So E Callisto needs some work on it to get all that software running because I remember um, I w I was trying to do the tracking for it, but then there was a problem with the tracking motor. Most
From
people
my
just point
understanding,
it due
my,
south.
yeah, from my
What?
understanding, the antenna moves daily. It was at that one point, it was moving every day. It
Yeah.
was
It
relocating in 3 different positions. It might be still doing that. It's just the software and the interface was the issue that was not connected, working.
yeah. It's not moving right now because there's a problem with the motor. and or the switches. So
Okay.
we powered off, but it turns out most E-Callisto equipment just has the antenna pointing toward the south. And
Yeah.
it just they split the difference during the day and they split the difference during for the seasons. And the log antenna is broad enough that it can collect data throughout the day. We were just trying to step up the game and follow the sun a little bit. And that's kind of a secondary goal. The first goal is we should get that working again to start reporting. I wasn't involved with setting up the computer, but I did look briefly at the instructions, and it was 475 steps of installing stuff. It was really an awful setup. So someone just needs to sit down and grind through that process to get things reporting. Any volunteers?
Yeah, you present this to a larger audience.
Yeah. Yeah, I'll probably write this up and briefly and see if there's anyone that's interested in taking these things on. Bill, so was that the only thing you're trying to remember? Bill, was the E-Callisto experiment, or was there
The interferometer
anything else?
issue as well.
Well,
What's that?
Myron's right. We've still got the interferometers that we would like to get installed.
Mhm.
And that's a whole nother subject that I won't get too deep into, but we do have at least one of the 3.8 meter dishes for an interferometer. And then the other one we were supposed to get back from Cumulus, and Ray was hooked us up with the Cumulus center. And we just need a team of people to go out and get it. And then, of course, we need foundations and everything for those and to get them hooked up. So that was one, and the other one that I had in mind was an on-site weather station,
Mhm.
so we can monitor our weather conditions both remotely and on site when we're in storm weather like we are now. Like today, a large thunderhead went out through that area. It would be nice to know that's coming, and it'd be good to monitor the weather station. So those are the others.
Well,
If
I
I
want
recall
to see
correctly,
Radio Joe put back up and back in operation too.
Yeah, that's right. We've in the past monitored Radio Jove, and right now that's down. But we could easily put it back up, and it's just a matter of hooking everything up and putting the dipoles back up and getting the receiver installed. But I don't think the original Radio Jove receivers that we have, I think we've got two or three of them, and those are not generally used anymore for Radio Jove. They've got a different setup, and we ought to look into that and see if we can modernize a little bit.
For anyone that might be unfamiliar, why don't you describe what Radio Jove is?
Oh, Radio Jove is a in the 50 megahertz range, a receiver, 20 megahertz range.
20 megahertz.
So it's a very simple receiver that was set up by the Radio Joe program was set up by NASA as a STEM experiment, actually, and very cheap little receiver. I think it was $100 or something for this little box. It interfaces the computer on the sound card of the computer or a USB, I think, on the more modern versions, and it monitors the radio signal that is generated between Io and Jupiter as Io orbits Jupiter, and Io, of course, is volcanic. It has a lot of plasma that is drawn off by the gravity field of Jupiter and a strong magnetic field between the two, and it creates a pretty strong radio signal that is really interesting to watch and monitor in the orbit of Io.
I didn't realize we still had the equipment for Radio Jove. I remember, reading about that and seeing it in the slides, but I didn't know that we still had that. So
Well,
that's awesome.
we
Yeah, we do.
probably want to just put up one of the dipoles is up. The other one came down to make way for the building, as I understand it. We got to put that one back up and then replace all that other stuff with a inexpensive SDR receiver. And I think that's probably all you need.
Yeah, I agree with Rick.
And a
It'd be
computer, of course, and all the rest.
yeah, that'd be far better than the this little receiver that they have is a fairly simple receiver and it's very broadband and not not real accurate.
So hearing all of this, my guess is probably the highest priority would be to get that dish before we don't have it offered to us any longer.
Yeah,
Would that
and
be a
I'm
fair?
waiting to bring my trailer over and park it where you want to pick up the dish.
Okay. Let me get together with Ray. I'm after the 30-foot dish. That should be easy.
Yeah, we've
So
had a lot of practice.
yeah, so let me get together with Ray and Rick, you can sit in the comfort of your air conditioned car and boss us around. How's that? With your, keep your feet off the ground.
I don't ever boss people around, but I do make suggestions.
Yeah.
Okay.
Oh, Roger, that one I know what the site looks like where this dish resides.
I've
And
heard some stories. Go ahead.
it's going to take about six of us. It's going to take six very able-bodied individuals to go
Well,
take
wait a
that
minute.
down.
It only took 8 of us, including my wife, to take the 30-footer down. You're saying it takes the same amount of effort to take this little baby apart?
Well, you had a crane and a crane operator.
Yeah.
Well, let's get a crane and a crane operator.
Okay.
Does it disassemble into petals like
Yeah.
the 30-foot
Yeah,
dish
we
did?
can do the pedals, taking it individually apart.
Yeah, I think it
Yeah.
comes out in
It's,
six or eight petals
it's right amongst several large trees as well that've grown up around it.
on a
Okay.
hill covered with four to 6 inch
Rocks.
river rock.
Yeah.
Oh, so basically the project's done when someone goes to the hospital.
Yeah, it's an ankle breaker. Yeah.
We took the
Okay.
last one. We took the last one down after a Saturday morning breakfast, but we did have a crane on that one. It was open in the clear and open, and that worked out quite well. However, this one it'd be hard to get something in there to take it apart with a crane. So taking the pedals apart would be the best thing, and which is doable.
Okay, and if no one else wants to spearhead that, why don't I go ahead and well, I should stop for a moment. Anyone want to spearhead this effort and get this rolling? Anne's smiling. She wants to do it.
Yeah,
I,
it's
I
one of
think you had the wrong mushrooms in your salad there, Roger. Sorry.
Okay. All right. Yeah. Of all the things, that sounds like that's not yet in our control, and probably we should get it
yeah.
before our chances have passed.
It's a nice dish.
Okay.
Yeah.
Heck, we can store it at my house, and I can set it up and try to do some satellite stuff with it. I'm sure my girlfriend would love that in the backyard. How big is it again? What's the
It's
diameter?
3.8 meters.
Hey, no
It's
Okay.
12 and a half feet.
Yeah. Okay.
No,
That's not
I
too
might
bad.
just keep it here at the house once I get
Yeah.
it.
Put it on the
I
trailer.
might set it up here.
There you go.
I'll have to cut down a few trees so I can see the sky.
Yeah.
Okay. So actually, I'm actually glad that I called this meeting because I had forgotten about a lot of these projects that we had in the wings and stuff. So that's good to know. So I'm kind of out of information here. I mentioned in my email that was probably going to be a short meeting. Does anyone have any
Well,
other?
I've got another one for a software guy. Looking for, do we know any software people?
For
Uh,
doing what?
well, for if you took all of these projects, there's probably 6 or 7 of them here that are individual experiments. And what I'd like to see is all of these rolled into one utility PC under one set of software control that we can log into and monitor all the experiments going on and say, okay, that one's working well. This is the data. That one's broken, that sort of thing. And it would only be one utility computer, so it would reduce our power load on the site. So it would reduce our power utility bill, on all these experiments.
Okay, so a lot of these experiments have their own dedicated, typically a Raspberry Pi or something like that, that everything is wrapped up, including the phone home capabilities. So what I could what I think would be probably a better solution would be some kind of central computer that could interrogate the databases that are being created by the people who are doing the studies.
Well,
Um,
that computer can easily be the new time and frequency computer. I have plenty of excess capacity on that one.
mhm. Okay.
We won't engineer it here, but yeah, you're right. And what you see what I'm trying to do. If we had one thing that was you have all these clients, and then we have all this one master that would
Mhm.
collect the information off all of these clients.
Mhm. But basically reduce the number of computers we have running on the site. Is that what you're trying to do? Reduce our power draw? Oh, you're muted, Bill. Still muted.
Yeah, for
There.
some reason I've been using the space bar. If anybody doesn't know that, in Zoom you can push the space bar and that takes you off mute. But somehow it got hung up in something else here, and so it's crawling across the chat window. So anyway, I won't do that anymore.
And we had something posted, internet weather station. Okay, so Ted posted something about the ambient weather stuff. I had a Davis for a while. I now have a oh God, what is it called?
A tempest.
Tempest. Yeah.
Yeah. Tony Hagen's said a couple months ago that he had a weather station that he might be willing to donate. I could contact him and see if that's true and see what his capabilities are.
Yeah. The
Could you?
ideal thing would be a Tempest with a hard interface, but we checked with them on that, and they only sell it in a Wi-Fi version. And we really want something that we can turn the Wi-Fi off on so we don't interfere with the radio astronomy. And so, but the Tempest is beautiful because when you do Tempest, you're in a network with all the other users. And if
Mm.
you've never looked at this, it's quite remarkable. There's so many stations out there. Colorado Springs probably has, close to maybe 1,000 Tempest stations, and you can look at a whole area. There's only two near us, one in Sugar City, I think, and one in Cheyenne Wells near Haswell. So it'd be really nice to have one of the
Oh,
Tempest systems out there, but they're
Tony
also Wi-Fi.
Tony lives in Sugar City.
Yeah,
Maybe it's his.
might be. I also
And
have two weather stations that came out of the National Geo observatories but the problem with them, they run on DOS 3.0 and they're ancient and they do work, but we could interface them, but they're so antiquated that I think we'd probably be better getting something more modern.
Yeah, and with the Tempest, even if it's Wi-Fi, if we could, fashion a switch into it to turn it off, um, that would solve that problem.
Yeah.
I kind of like the Wi-Fi communication, or it's actually not Wi-Fi. The Tempest has its own frequency, because my Tempest unit is the receiver is plugged in, but of course, between the receiver and the Tempest weather station itself, is some frequency. I don't know what, but the advantage of that is then, if you have a nearby lightning strike, you're not frying equipment.
Yeah, we'll look into this thing that Ted has, this ambient WS 2090. Is that Wi-Fi, Ted? Where is that wired?
That is Wi-Fi to a display, which then talks internet, I guess, Wi-Fi on the inside. Yeah.
Yeah.
I'll let you study it. There's the link to ours to show you
Okay.
what it provides.
Okay, appreciate that.
Yeah,
Go
when I had
ahead.
my Davis Weather Underground was what my Davis reported to. And it was interesting being able to look at all the stations around to see how the weather was changing, as well as being able to identify the stations where people didn't know which direction north was.
Mm.
Okay.
All right.
Well, that kind of clears all those, but you can see that we've got a number of experiments. If we can roll them all together, that'd be great. If we can get them all running, that would be even better because the beauty of the site is that it's a very remote site. There aren't too many radio signals around there. Um, it's a quiet site, so we get the electronics is quiet, and it'd be nice to be able to get some of these experiments rolling and
How to connect
actually
Weather HL.
do some science. Go ahead.
That might have just been a unmute mistake.
That's okay. Okay.
Um, so yeah, I'm leaving this with we should probably get hopping on that dish. Is this where is it? Is it in town or is it up on Cheyenne or
It's in town. It's at the Tiffany Square, the old Tiffany Square shopping center, which is now the Cumulus, and college. One of the colleges occupies half of the building and or half
the
of the
U-Haul place?
no, it's down off of Woodman and I-25.
Off U-Haul now. College went away. Yeah, the college went away. It's all U-Haul place now.
I'm sorry, what was that, Myron?
Can you hear me okay?
Yeah.
I said it is the U-Haul building because the college went away.
Oh, it is the U-Haul. That's right. The U-Haul did move in there.
Yeah.
God, that's next door to me just about.
Yeah. Well, you could
So-
drive over there, and it's on the south side of the building, in the trees. There's several dishes in the trees there, and you could take a look at that location if you're near there.
I'll do that.
Yeah, but it's on the west side of I-25.
Okay.
I think it's called Tech Drive.
Mm,
You go through I-25, and the next road turns south, and that goes past the shopping center there, and it's in the back, in the south side.
just a moment here. Here, I'm going to share again.
Yeah, it's on the same road there.
Yeah, I can't think of the name. It's Tech Center Drive is what it's called.
Can you see this?
Yep. It's right there where your cursor is.
Okay.
Yeah.
So it's somewhat, well, there's a parking lot here.
Yeah, it's
Let
so
me go
that
there.
little where that center jets out there towards the parking lot on the south side there, that's where it is.
Hold on. My map froze. Let's try this. Okay.
You might
So
be
tell
able to
me
see-
again.
See those
Let me-
trees? See that green bunch of trees right there next to the parking lot on the very south corner of this thing?
Here?
Right there. Yeah, that's where it is.
It's in those trees, yeah.
Oh, wow. The way you described it was rocky and stuff like that. I thought we were going to be
Well,
climbing down
under
some-
under those trees, it's a hillside and it is rocky. Yeah.
Okay, but I was picturing that we were having to go, 30 feet down some embankment toward the river or something like that.
Oh, it's off. Go up to your right. You see the dishes up to your right, right there.
Oh, there we go.
Oh yeah, there they are. Okay. I was in the wrong place. Yeah.
There.
Which one is it?
It's the smaller one.
Down
This
below.
one?
Yeah.
Yeah.
That one.
It's kind of hidden.
Yep.
The road closest to the parking lot.
Oh, cool. Okay.
Looks simple. Go look at it.
All right. No, that's good to know. All right.
They got a
All
great
right.
food restaurant there too.
Yeah, good restaurant. Good Mexican restaurant. Right? Okay. So
All right.
back to your main subject.
Well, I think we pretty much, wow, we basically covered about 250% more than my main subject, with all the other things that are going on. But at this point, I've pretty much covered everything I wanted to cover and more. Does anyone else, have any topics to bring up or questions to ask?
Oh, your Tempest weather station
Yeah.
broadcasts on 915 megahertz.
Okay, that's one of the ISM bands.
Yeah,
And we could shut that off if we could wire into it and shut it off.
yeah, I suppose you could. And it only transmits when it has new data. So no more often than once a minute for a burst.
Huh.
I think that the that my wind direction updates much quicker than that.
That's updates every 3 seconds if you do wind direction. Yeah.
Okay.
Yeah, and I think it's somewhere in there it translates to Bluetooth or Wi-Fi because it gets it into your computer or your phone.
That's the base station inside
Yeah.
that does that translation, and that's easy to turn off.
Yeah.
The outside unit might not be quite so easy.
Hmm.
I mean, I have mine mounted at about, head height. So if we just did that, it'd be easy to walk out. Um, I
So,
forget um, how the batteries are in there, but we might have to actually wire an external switch.
Well,
Make it
and
easier
it
to
may
turn off.
not be necessary. We can try it and see. Uh, a low power burst signal on 900 megahertz is unlikely to affect our radio astronomy at 400, 600, 1400, and 1600 megahertz.
Hmm.
It's not
And,
likely to be a problem.
and that's always my philosophy is do nothing, see if there's a problem, then solve it instead of anticipating problems and adding complexity.
yeah, we could try it. Yeah, well, Roger, you have one. You've got a spectrum analyzer. You could take a look at it and see what you see and see if there's any clean way to do this.
I
Which
actually don't have
which
a spectrum
model
analyzer.
You can borrow
which
mine.
model do you have, Roger?
What
Which mo
model? Um, I'm unsure.
Oh, I don't
Um,
know that model number. I haven't heard of. I'm unsure. Most of them start with W.
um,
Yeah, we while he's looking, we actually called the company that makes this thing, and we said, "Do you have a wired version? And
Yeah,
is there a clean way to turn this off?" And they said, "No, we don't have that, and we don't intend to make one." So they weren't really willing to help us.
no, and they power it by solar charging the batteries, so
Yeah, that's true.
it's really hard to turn off.
Yeah, the great thing about I think the best thing about the unit is it has no moving parts. And it also, well, if it has a moving part, it would be the rain sensor with a little valve, a little solenoid valve. But it
no, it
measures.
doesn't. It doesn't have. It actually. It measures the impact of raindrops. So there's like
Oh,
a
so it, yeah.
So
Hmm,
yes, there's no like dump or seesaw thing like the
really,
Davis has,
that's very cool.
and
And
and then
also
it,
has
ultrasonic wind.
ultrasonic wind, so it has a ultrasonic anemometer and tells where the wind's coming from with that. And so there's no wind vane to tear off. Or the last weather station we had at the site ended up the little anemometer little cup thing ended up in Kansas. And so it was gone before we could even use it. But that's the beauty of the thing. Plus, it measures lightning distance and frequency and all that about lightning, which is even cooler because I've been out there many times where we wonder, well, how far off is the storm that we're trying to work around? And having a lightning sensor that told us, where it was and how far off it is, that would be very handy.
Yeah, I don't believe it has a lightning sensor. What I think it does is it taps into, like the National Weather Service or something like that, and knowing the location of your equipment, it computes where the lightning, is and how far away it is. So I
Yeah,
don't believe it itself, because you need three locations in order to
generally.
triangulate for lightning. So I don't think it has a lightning sensor in it.
So
There,
there's an
there
experiment
is
if somebody,
there is an optional lightning sensor, but you're right, it only measures distance, not direction.
ah, yeah, there's a project for somebody if they wanted to come up with a true direction and distance lightning sensor. That would be a really great project.
Okay, I'm going to go down a rat hole. How do you measure distance? I mean, when you can
Arrival.
record.
Well, you got three sensors spaced at some distance, out 100 meters or something, and you look at arrival time to each
Okay,
sensor, and you triangulate, and you can do the geometry and get distance.
okay, if you have multiple sensors, yes, but if it's just one sensor, you can't. You can certainly accurately tell when the EMP hit you, but that doesn't give you distance.
Right. Well, another way to do it would be the EMP versus the audio.
Yeah, that's the only thing I could come up with is
Yeah.
is yeah, listen for it, but that's usually spread out over, the further away it's a broader and broader audible signal.
Right.
So,
Yep. Yeah.
how do you
Scintillation.
yes. Okay, we're down a rat hole. I'll instead of yakking forever here, I'll just again ask is there anything else that anyone would like to bring up in this meeting? Any questions about anything we've talked about? Okay, so at this point, I will turn the recording off, and everyone is. I will not exit the meeting immediately, but everyone can certainly hang around and chat if you like, or or if you've had um, enough from everyone, you're welcome to drop off. Thank you very much for showing up. I'm sorry about the disorganized meeting here, but actually, I did get reminded of a bunch of stuff I had forgotten. Thanks.
Well, I appreciate you taking over the meeting, Roger. I had forgotten that it was the fourth Monday.
Oh, okay.
Since the first Monday was on the first of the month, it snuck up on me.
Hmm. I hope I recorded this. We'll find out.
And usually it's just when you stop recording, it'll say something, but I haven't heard that.
Yeah, and I've been clicking on it. Maybe it recorded the whole thing with
Well,
the
Yeah.
I'm
chatting at the beginning.
I'm
Yeah,
getting the transcript is being recorded and it's picking it up nicely.
Okay.
yeah, it said the recording was on. We were late logging on and it told us that it was recording.
Yeah.
So you must have got it.
Okay.
I think it's still recording. That little
Well,
dot's hard to tell what color it is, but it's blinking at me.
well,
So
I've clicked on it and it goes from bright red to dimmer red, but then it comes back to bright red.
Hmm.
So I obviously
Yeah.
I'll have to look and see how the
it's
recording
recording.
works. The reason I keep looking off to the right is I actually am running the meeting on a Chromebook. I'll hear off to my right, where I'm using my computer for the actual for my presence in the meeting.
Yeah.
And it seems to be kind of working out fairly well. So Rick, where are you here in Colorado, or are you down in Oklahoma?
We are here in Colorado. We are heading out tomorrow, uh, probably around noonish, we hope. If not, then we will be leaving Wednesday morning. We'll be down there for about 2 to 3 months and um, helping one of the clubs put up repeater. We got ground, um, a leash on some ground and stuff like that. And then, of course, field day, we'll be down there for field day and a whole bunch of fireworks down there. So, um, so we'll be playing down there for a couple, 3 months, and we'll be back up here for a while. I think we got this snowbird and stuff backwards. We seem to be spending the winters in Colorado and the summers in Oklahoma.
Yeah.
There,
So
Myron's
actually,
got a great picture of this dish there.
No, I know.
There it is.
I think it might be the one that's closest to the building, Myron. The other one, the pedestal's on the ground, but the other one's up in the weeds or up in the rocks.
Yeah,
I think it's the big one. That one up closest to the building.
it's the one right there in the trees to the right.
Yeah.
oh, so you think it because that one there's really no rocks to walk across.
Yeah, there is.
Well, so move, zoom out and move over to the right a little bit more.
Yeah, trust me, there's rocks to walk across.
So I don't think it's this one then because there's no rocks there.
Yeah, that's right.
Yeah, there
Yeah.
is. You got to get on the front side of it. It's the one in the trees that you're looking at, the closest one.
Is it okay? But you got to get up on the rocks to take it apart.
Yeah.
Okay.
And that's a pretty good slope on these big rocks. And we walked up in there, and it's hard to keep your balance. And getting a ladder in there, that's going to be a real issue.
Yeah.
And it's hard to cherry pick it because it's in the trees. We could get a crane and just cherry pick it out of there, but the trees are pretty tall, and the trees are in the way.
All branches in the way, yeah.
Yeah.
Trees.
I'm getting dizzy.
Yeah. Going back to the lightning issue, one thing we've never done at the on a remote station down there is lightning protection for the radios in the bunker. They stay connected all the time. Years ago, when we'd leave the site, we would disconnect all the antennas. Now that's not the issue because and we could easily put some relays in there to disconnect antennas if there's thunderstorms in the area. There is a device commercially made that can handle up to 4 antennas that I've seen that could automatically disconnect the antennas, and it's actually connected through the internet to a website that tracks lightning and thunderstorms. And if you set it for a 10-15 mile radius, it will disconnect all the antennas automatically and then reconnect them once a thunderstorm goes by. A friend of mine uses that for his remote station in California.
Yeah, don't tell Paul or he's going to want to buy it.
Yeah, I know.
What's one of these cost?
It's cheaper than new radios or an amplifier.
Well, that's true. But if it's a couple $1,000 for a switch like this.
Oh, it's like $450, something like that.
Yeah.
But yeah, you're right. It's something has to be done. I keep telling Paul, and he said that's not an issue.
Well, one of the things that one of the projects that's on the list is to ground and bond the radio system console in the building and do the ground rods around the towers and around the building and tie everything down and try to mitigate the lightning as much as possible. That would help a lot, but that's a very laborious and expensive project because we need a lot of ground rods and a lot of strap. And I think we got the strap, but ground rods I'd have to buy a probably for the building and the towers. I had it scoped out at one time, but it's probably about 25 of these 8-foot ground rods, and then we have to have something to drive them with. So that thing's called a dual antenna disconnector, and you say they have a 4-channel one, huh?
I was going to ask if this is what you're talking about.
Yeah, that's not the one I was. It's a different brand, different model.
Okay.
Yeah, but it I don't know how that one works, but this one is connected via LAN cable to the internet. So
Does it do a grounding of the antenna through the relay?
Grounds everything, disconnects the antennas and grounds.
Grounds them, right?
Yeah.
Doesn't leave them open.
Once we're in the building, the lightning will be a bigger issue because of the dish nearby and all the grounding that we'll have in. So but in the bunker area, we've been very fortunate not to have any direct lightning strikes down there on that tower.
Yeah.
It's just a matter of time.
Do,
Not
do
that it,
we do we have any kind of arresters like the Alpha Delta
Nothing.
lightning arresters or anything on those?
No.
Oh wow. Okay.
hmm.
Right now, I guess the remote station, and you were down there with Ray, the remote station, according to Ray, is not working due to antenna issues on 6 meters.
That is correct. It appeared to be a cable issue that was, as I recall, about 60 feet from where the receiver is. It's partway up the tower, and sensibly, he said, "I'm not going up that high." So that was the information derived from his antenna analyzer.
Yeah, okay. That's kind of what I got from a text message from Ray earlier today. So yeah, there's a lot of that, and that system was put in. We didn't have all the resources necessary like we do today, and a lot of cable. I think there's maybe several splices of RG8 into that antenna system. I know there was on the tri-bander as well as I'm pretty sure there was one on 6 meters because we didn't have long enough coax.
Yeah,
So
Ray's recommendation was simply to put up an entirely new cable that's a single piece and get around that issue.
LMR 600, we could easily run up the tower if we're going to keep that A station in the bunker, which would probably be the best place to keep that station out of the operating center.
Well, yeah, Paul just put out a note that he was going to talk to Tony and go ahead and install the towers and move the station as soon as possible.
Yeah, there is a problem here, Myron.
Yeah.
That antenna that piece of coax connects to is mine.
I know, yeah. And that
So
tri-band,
I'm taking the antenna. You can replace the coax if you like, but while you do it, I want to take the antenna down so it won't
I'm
feed
taking
anything.
back as well.
So the new antenna is supposed to go on the tower by the new building.
Yeah. We got three
And
HF
that's-
tri-banders down there, and mine is number 4, which was been on loan for 10 years now, or over 10 years.
Yeah, I understand.
I looked for them. I couldn't find them. Where are they, Myron?
They're down there. Well, I hauled them down with Ray, hauled them down.
Okay.
3 tri-banders.
Uh,
2 of them are the same brand. One's in the garage. That Step IR, Urban Step IR, which is I won't say it, but it won't be. I don't know. I think it's useless to put that thing up down there. As fragile as those antennas are.
yeah, we'll be maintaining that thing all the time.
Yeah, they're very intensive, and it's hard to get parts for them when they do break.
Yeah, anything with moving parts. Well, anyway, so yeah, we got a lot of work to do. It's all on the list, and we keep adding to the list. So I don't know. I'm going to talk to the board about this tomorrow, and how we want to go about prioritizing the list of things. But we keep adding projects, and whenever anybody adds a project, then all of a sudden that becomes a priority. And so it should be at the bottom of the list rather than be the priority, But we keep coming up with stuff to add and spend money on. So we should take a look at that and prioritize the list.
Okay. Is that it for everyone? Hearing no dissenting voices. Tell you what, at this point, I will terminate the meeting and give everyone back their evenings. It lasted an hour. My God, I'm quite surprised. I thought I didn't have anything that would take more than 15 minutes. So, all right. Well, thank you all for attending the science meeting. We'll see you in a couple of weeks at the engineering meeting.
Thanks, Roger.
Take care.
All right. Thanks, Roger.
All right. Bye-bye.
Bye-bye.